Here a problem on uh, parallel plate capacitor and energy stored in the capacitor. So we have got a parallel plate capacitor which has uniform electric field E in between the two plates. So there are two plates, in between them electric field is uniform, which is given as E. If the distance between the plates is D, the distance between these two plates is just D, and area of each plate is just A, then the energy stored in the capacitor is, so we just have to write energy stored in terms of these three factors. So answers are here. There are four options. We just have to write what is the energy stored. Let's go to the result of energy stored in a capacitor. We can write energy stored in the capacitor in terms of capacitance and potential difference between them. That is half CV square, where C is the capacitance of the capacitor and V is a potential difference between them. Now answers are, so this is energy. Do not confuse with this E and this E. This E is actually electric field between these two plates of a capacitor. Now answers are not in terms of this C and V. We just have to write in terms of all this EAD. So how would you do it? Given that the capacitor has a plate in which the area is A and the distance between the plates is D, we can write capacitance of the capacitor in free space E as epsilon naught A by D. And the potential difference, there is a relationship between electric field between the plates and the potential difference between the plates, V by D. So E is equal to V by D. That means V is equal to E into D. So let's substitute these two here. So energy is equal to half C is epsilon naught A by D into V square is the potential difference between the plates, that is E into D, V square, ED square. So that is equal to 1 by 2 epsilon naught A by, so this is E square D square, 1D cancel here, you are left with E in E square into D. So answer is here half epsilon naught A E square A into T.